Hello everyone, welcome to IB. Myself Satya Kalaimani. Today we will be dealing with the topic geomagnetism and geomagnetic reversal. We are happy to launch this new initiative where we'll be discussing various topics relating to UPSC. And today's class would be a topic on geography, that is geomagnetism and geomagnetic reversal. So adu paakradhukku munna இந்த topic oda relevance enna appdin theriyum. Why this topic is relevant? Okay, so these are some of the news reports and articles which are relevant to today's class, right? Here we can find these words like geomagnetic storms. The Earth's magnetic poles are swapping or they are wandering. And this is a news article which talks about the relationship between your northern lights, or what we call as the auroras, with the geomagnetic storm. So these are more repeatedly occurring areas and more interesting topic in your geography, right? So let's start. In the session oda objective enna, after completing this session என்னென்னலாம் நீங்க புரிஞ்சு வச்சிருப்பீங்க அப்படின்னா, first அதோட basics, that is what do you mean by geomagnetism? Geomagnetism na enna first. Second, what causes geomagnetism? Geomagnetism gra property earth ku eppadi occur agudhu? We explain the causes with the help of many theories. Okay, we will talk about the most recent theory quite elaborately. So what is geomagnetism? What causes geomagnetism? Then comes the conceptual part. These are your basics. Next, your conceptual area, where we will try to understand the different poles on Earth's surface. Poles, now, one thing which we are all aware of, that Earth has geographic North Pole and geographic South Pole. And some of you might have aware of Earth has magnetic North Pole and magnetic South Pole. And there is third important pole, which is known as geomagnetic North Pole and geomagnetic South Pole. So idella enna, what are the differences? Next, we will try to understand the significance or relevance of geomagnetism or your geomagnetic storms. Okay, and lastly, we're going to revise this topic with the help of questions. We will solve 2 to 3 objective type questions to get much more clarity into the topic. So through questions also we will learn some important relevant facts. Okay, shall we? So first is first. First enna paaka porom, what is geomagnetism nu paaka porom. Geomagnetism, how we define geomagnetism, is a study. Edha pathina study? It will study the dynamics of Earth's magnetic field. Okay, Earth's magnetic field oda dynamics padikkiradhu da geomagnetism. Dynamics na meaning enna? The Earth magnetic field is subjected to changes or subjected to variations, right? So what is Earth's magnetic field? How Earth has a magnetic field? It is believed that Earth acts as a bar magnet. Assume this is my Earth and Earth acts as a bar magnet. Bar magnet na enna? Why we talk about as a bar magnet? Because bar magnet has polarity. அதாவது ஒரு பார் மேக்னெட்டை எத்தனை பீஸா நீங்க டிவைட் பண்ணாலும் அந்த பார் மேக்னெட்டோட போல்ஸ் அதே மாதிரி தான் இருக்கும். It will retain the north pole and south pole. Similarly, Earth also has poles, 2 important poles, the north poles and south poles, and the magnetic field lines. Since Earth acts as a bar magnet, the magnetic field lines emerges out of one pole and converges into the another. Okay, so vella emerge agum, இன்னொரு போல்ஸ்ல அந்த magnetic field lines converge ஆகும். இந்த லைன்ஸ் தான் magnetic field lines னு சொல்லுவோம். இந்த magnetic effect எந்த அளவுக்கு எக்ஸ்பீரியன்ஸ் ஆகுதோ அந்த என்டையர் ஸ்பியரை மேக்னெட்டோஸ்பியர் அப்படின்னு ரெஃபர் பண்ணுவோம். Magnetosphere, right? So magnetosphere is the zone we can feel the Earth's magnetic effect. It extends up to 60,000 square kilometer. Magnetic field lines oda distance evlo? It is approximation da 3,200 kilometers from the Earth's surface lende we can find the field lines. And the magnetic field lines oda impact evlo dooram verikum irukkalam? 60,000 kilometers verikum irukkalam. And foremost important aspect in the magnetic field line oda very important aspect is that it acts as a preventive shield. It acts as a preventive shield. It protects the Earth and its atmosphere. Okay, it protects Earth and its atmosphere. from the harmful impact of solar wind or solar flares. So solar wind இல்லனா solar flaresல இருந்து earthையும் அதோட atmosphereையும் பாதுகாக்கிற ஒரு பெரிய ரோல் என்னோட magnetic field linesக்கு இருக்கு. Okay, since we described, அப்போ earth பொறுத்த வரைக்கும் என்னோட geographical north pole and geographical south pole need not necessarily be, okay, need not necessarily be my magnetic north pole and magnetic south pole. We all know, if this is my equator, இங்க இருந்து center of earthல இருந்து 90 degree north அப்படிங்கிறது geographical north pole. அதே earthோட centerல இருந்து south pole 90 degree southங்கிறது geographical south pole. Whereas the bar magnet or the magnetism field lines ஓட emergence and convergence, it happens slightly different from your geographical north pole and south pole. It has a deviation. In the deviation inclination சொல்லும். Okay, okay, look into the diagram. So என்னோட geographical north pole இருந்து கொஞ்சம் deviate ஆகிதான் என்னோட magnetic north pole இருக்கும். ஓகே, இதே என்னோட ஆப்போசிட் ஸ்பியர்ல சவுத் போல்ல இருந்து கொஞ்சம் டீவியேட் ஆகிதான் என்னோட சோ கால்டு ஜியோமேக்னெட்டிக் சவுத் போல் இருக்கும். சோ அட் பிரசன்ட் கேசஸ் இது எங்க இருக்கு? 90 டிகிரி நார்த்ல இல்ல, இட் இஸ் அட் அன் ஐலண்ட் நியர் டு ஆஃப் கோஸ்ட் ஆஃப் கனடா. ஜியோமேக்னெட்டிக் நார்த் போல்ங்கிறது கனடால இருக்கு. அதே என்னோட ஜியோமேக்னெட்டிக் சவுத் போல் அப்படிங்கிறது பசிபிக் ஓஷன்ல ஆஃப் கோஸ்ட் ஆஃப் அண்டார்டிகா. அண்டார்டிகாவோட ஆஃப் கோஸ்ட். இன்னும் சொல்ல போனா இட் இஸ் அவுட் சைட் யுவர் அண்டார்டிக் சர்க்கிள். ஸோ இதுதான் என்னோட ஜியோமேக்னெட்டிக் லைன்ஸ், அதனால வரக்கூடிய மேக்னெட்டிக் போல்ஸ். ரைட்? Now, as I've told you earlier, there are 3 poles. Earth is the planet which have 3 distinct north poles. North poles மட்டும் consider பண்ணாலே I have 3 distinct north poles. Similarly, we have 3 distinct south poles in your southern hemisphere. First is your geographic north pole. Okay, geographic poles அப்படிங்கிறது என்ன? earth rotate ஆகும் இல்லையா, earthக்கு rotation motion இருக்கு. so எந்த axisல earth spin ஆகுதோ அந்த axis தான் geographic north pole and geographic south pole னு சொல்லுவோம். இதுல நோட் பண்ண வேண்டிய conceptual part is this: it is an antipodal point. Antipodal point na when you connect these 2 points, that is the geographical north pole and geographical south pole, when we connect these two, the line passes through the center of earth. அந்த earthோட centerல pass ஆகும். அந்த ரெண்டு பாயிண்டையும் கனெக்ட் பண்ணா அந்த லைன். Okay, that is your geographical north pole and south pole. Next comes your geomagnetic pole and your magnetic pole. Okay, ரெண்டு இருக்கு, magnetic poles and geomagnetic poles. Magnetic poles அப்படிங்கிறது இப்ப நம்ம பார்த்தோம் இல்லையா, எந்த இடத்துல என்னோட so called magnetic field lines converge and emerge ஆகுதோ, earthல எங்க converges and emerges ஆகுதோ அதுதான் என்னோட magnetic poles, which is mostly does not coincide with my north pole. கொஞ்சம் தள்ளி தான் இருக்கும், அதுதான் inclination னு சொல்லுவோம். சோ கொஞ்சம் deviate ஆயிருக்கும். என்ன இதோட பிரத்யேகதை அப்படின்னா, இந்த magnetic poles are not antipodal. Not antipodal na, what does that mean? When I join the point of emergence of my magnetic field line, and when I connect the pole through which the convergence of magnetic field line occur, it does not passes through the center of earth. It will does not, இது center of earth na, எந்த பாயிண்ட்ல இருந்து மேக்னெட்டிக் ஃபீல்ட் லைன்ஸ் ஆரிஜினேட் ஆகுதோ, டைவர்ஜ் எமர்ஜ் ஆகுதோ, எந்த பாயிண்ட்ல மேக்னெட்டிக் ஃபீல்ட் லைன்ஸ் கன்வர்ஜ் ஆகுதோ அந்த ரெண்டு பாயிண்ட்ஸ்மே அதுதான் மேக்னெட்டிக் போல்ஸ் இல்லையா. மேக்னெட்டிக் ஃபீல்ட் லைன்ஸ் வெளில வரக்கூடிய, மேக்னெட்டிக் ஃபீல்ட் லைன்ஸ் உள்ள கன்வர்ஜ் ஆகக்கூடிய இந்த ரெண்டு பாயிண்ட்டுமே கனெக்ட் பண்ணோம் அப்படின்னா அந்த பாயிண்ட்ஸ் என்ன ஆகாது, இட் வில் நாட் பாஸ் த்ரூ தி சென்டர் ஆஃப் எர்த். தே ஆர் நாட் antipodal. So what we will do, we will select some place which is closer to the magnetic poles. இந்த மேக்னெட்டிக் போல்ஸுக்கு பக்கத்துல நியர்பை ரீஜியனை ரெண்டு செலக்ட் பண்ணுவோம். so that when I join these 2 points, it will pass through the center of earth. so I will select 2 points which are antipodal in nature, similar to my geographic north and south. geographic north pole south pole ஜாயின் பண்ணா அதோட லைன், அது ரெண்டுத்தையும் ஜாயின் பண்ற லைன் earthோட சென்டரை கிராஸ் பண்ணும். similarly, magnetic poles பண்ணுமானா பண்ணாது. magnetic poles ரெண்டுத்துமே join பண்ணோம் அப்படின்னா அது earth-ஓட center-அ cross பண்ணாது. அப்போ what we will do, we will select a nearby location. Okay, we'll consider that as the geomagnetic. Now I include geo here, meaning enna, these two magnetic points or the locations on earth's surface will pass through the center of earth. When I connect them, when I connect these two magnetic poles, it will pass through the center of earth. Such type of magnetic pole is known as geomagnetic poles. அப்ப நம்ம நார்மலா நோட் பண்றது என்னது? Geomagnetic poles. If this is the aerial view of your north pole or your Arctic region, I have my geographical north pole. இது என்னது? 90° north. north magnetic poleங்கிறது என்ன? north magnetic poleங்கிறது எந்த இடத்துல என்னோட magnetic field lines converge ஆகுதோ அது actual convergence. What is geomagnetic pole? Geomagnetic pole is a location near to the magnetic pole where when I join the geomagnetic north pole and the geomagnetic south pole, it will pass through the center of earth. Such type of location is considered as north geomagnetic poles. Right? Idla innu ore oru word idla you can find a dip here. Magnetic poles eppadi define பண்ணுவாங்கன்னா, it is where the earth's magnetic field points directly downwards. Okay, in the concept, for example, we have a magnetic compass. We all have magnetic compass. And where do the magnetic north points? It points the magnetic north pole. Yeah, magnetic north pole enga irukko anga da adu point pannum. Oruvela na magnetic north pole liye nikkiren appadina appa enoda magnetic compass suspend panna, where it will point? It will point downwards. It will dip. Getting me? அது வந்து சஸ்பெண்ட் ஆகாது. இந்த மாதிரி ஏர்ல சஸ்பெண்ட் ஆகாது. நம்ம டைரக்டா நார்த் போல்ல நிக்கிறோம் அப்படின்னா என்னோட மேக்னெட்டிக் காம்பஸ்ல இருக்கக்கூடிய லைன் இல்ல அந்த காம்பஸ் நீடில் இட் வில் பாயிண்ட் டவுன்வர்ட், எக்ஸாக்ட்லி டவுன்வர்ட். அதுதான் டிப்னு சொல்லுவாங்க. சோ மேக்னெட்டிக் போல் ஆர் நார்த் டிப் போல் ரெண்டுமே சேம் தான். இத எக்ஸாக்ட்டா அந்த ஃபீல்ட் லைன்ஸ் கன்வர்ஜ் ஆகுற பாயிண்ட். ஆனா அது அந்த ரெண்டு பாயிண்ட்ஸை கனெக்ட் பண்ணா எர்த் சென்டர்ல பாஸ் ஆகாது. அதனால நம்ம என்ன பண்ணுவோம், எர்த் சென்டர்ல பாஸ் ஆகக்கூடிய மோரோர்லெஸ் மேக்னெட்டிக் போல்ஸுக்கு பக்கத்துல இருக்கக்கூடிய லொகேஷனை தான் மேக்னெட்டிக் போலா கன்சிடர் பண்ணுவோம். அண்ட் we term that as geomagnetic poles. I hope you all understand. Three important poles: geographical north pole, exacta 90° north south, and it is antipodal. Magnetic poles are the locations where magnetic field lines emerges out and magnetic field lines converges in, but that are not antipodal. Right? When we connect these 2 points, they do not pass through the earth center. So what we do, we will select another location much more closer to your magnetic poles, which passes through the earth center. When we connect these 2 points, it will pass us through the earth center, and that points are known as geomagnetic poles. So we have geomagnetic north pole and geomagnetic south pole. From this diagram, the diagram it is your geomagnetic north pole we are talking about, and the geomagnetic south pole. So off coast of Canada and off coast of Antarctica irukkodiyadu geomagnetic north pole, meaning when I connect these 2 points, it will pass through the center of earth. They are antipodal. Okay, now comes the next question: is my magnetic poles or my geomagnetic poles fixed or permanent? The answer is no, a big no. They are subjected to change. Right? We will learn what causes magnetic property. We all relate everything to the earth structure or earth's interior, especially the core. So there are so many changes happening in the earth's interior. Therefore, the magnetic property or the magnetic field lines, they do not converge on the same position. Earth or evolution 4.6 billion years earth evolve ஆயிட்டிருக்கு. So the magnetic poles are subjected to change. The geomagnetic poles are subjected to change. This is an illustrative diagram where it pinpoints the movement of your north pole. Okay, so from 1620, year 1620 lerundu we can trace the movement, how my north pole is moving, and presently where it is. Presently the North Pole is been off coast of your Canada. So in the madriyana or wandering movement, it is not fixed. The poles are shifting. It is always shifting. Why? Because the changes happening in the Earth's interior is the causative factor. Appo changes எந்த அளவுக்கு டைனமிக்கா இருக்கோ அந்த அளவுக்கு magnetic poles move ஆயிட்டே இருக்கும். இல்ல ஒரு சின்ன கான்செப்ட் என்ன, that movement was very slow for say 9 kilometers a year. ஒரு வருஷத்துக்கு ஒரு 9 kilometer மாதிரி மூவ் ஆயிட்டு இருக்கும். Whereas recent times the increased activities of solar energy, sun's increased activity or the climate change, what happened, there is a recent movement. It is moving very fast. For example, it moving at 20 kilometer per year. இப்போ ரொம்ப ஃபாஸ்டா என்னோட மேக்னெட்டிக் போல்ஸ் வந்து ஷிஃப்ட் ஆயிட்டு இருக்கு. எங்க இருந்து? கனடால இருந்து டுவர்ட்ஸ் ரஷ்யா. Okay, the magnetic poles are moving from the off coast of Canada to Russia. And it is moving fast. இதெல்லாம் தான் அந்த நியூஸ் பேப்பர் ரிப்போர்ட்ஸ்ல earlier காமிச்சேன் இல்லையா, அந்த செஷன் ஸ்டார்டிங்ல இதெல்லாம் பத்தி தான் பேசுது. The movement is becoming faster. Now comes the very general question. Is polar reversal possible? ஷிஃப்ட் ஆகுது, அது வந்து பெர்மனன்ட் இல்லைன்னு நம்ம பேசிட்டோம் இல்லையா. மேக்னெட்டிக் நார்த் போலும் மேக்னெட்டிக் சவுத் போலும் பெர்மனன்ட் கிடையாது. எந்த இடத்துல மேக்னெட்டிக் ஃபீல்ட் லைன்ஸ் சேஞ்ச் ஆக ஆக என்னோட போல்ஸும் சேஞ்ச் ஆகிக்கிட்டே இருக்கும். அண்ட் தே ஆர் மூவிங், தே ஆர் ஆக்சுவலி ஷிஃப்டிங் at a faster rate, at a slow rate, that depends. Okay, so is polar reversal possible? அதாவது present day magnetic north pole and the present day magnetic south pole, will they able to swap their places? அதுதான் polar reversal சொல்லுவாங்க. Is it possible? Is it so? Yes. This is known as geomagnetic reversal. அதாவது today we have the magnetic north pole near to your Canada coast or much more closer to your northern hemisphere, and this is the opposite. This is where your geomagnetic south pole occurs. So what do you mean by geomagnetic reversal? After a geological time, after a considerable time gap, there is a possibility that the magnetic north pole would shift from your northern hemisphere to your southern hemisphere. This is possible, but the catch is that it happens as a very, very slow rate, approximately at current rate la solnona, with a gap of 30,000 years, 30,000 million years. There is a possibility. Scientists are suggesting that polar reversal could happen. Okay, so this is how. When Earth was initially formed, the reversal occurred, or the time gap between your magnetic reversals was 10,000 years. 10,000 years is also not a short duration. 10,000 வருஷம்ங்கிறது அதுவே பெரிய டைம் கேப் இல்லையா, ஜியாலஜிக்கல் டைம்ல ரொம்ப பெரிய கேப். அது என்ன சொல்ல போனா ரீசன்ட் டைம்ல இருந்து 10,000 years அப்படிங்கிறது தான் என்னோட ஜியாலஜிக்கல் டைம் ஸ்கேல்ல மாடர்ன் மேனோட எவல்யூஷன். Okay, modern man started from recent to 10,000 years ago. So that was the minimum shortest time, and it can take as long as 25 million years. It is very, very slow. Okay, இதுல இன்னும் ஒன்னு நோட் பண்ண வேண்டியது, polar reversal can happen in sun also. Sun also experiences geomagnetic reversal, but it is very, very faster when compared to Earth. Earth can minimum 10,000 years, maximum pona 25 million years time ஆகும். Sun பொறுத்த வரைக்கும் it can happen every 11 years. Every 11 years, because sun is a hot volatile ball of gas, so the changes is so dynamic, so rapid. So every 11 years the geomagnetic reversal happens in your sun, which is very, very fast, comparatively very fast. Whereas in case of Earth, it could be very slow as 10,000, and it could be very, very slow to 25 million years. Okay, that is all your basics. Now comes the conceptual area. What causes geomagnetism? ஏன் ஜியோமேக்னெட்டிசம் நடக்குது, ஏன் எர்த்துக்கு வந்து மேக்னெட்டிக் ஃபீல்ட் லைன்ஸ் இருக்கு, மேக்னெட்டிக் ப்ராப்பர்ட்டிஸ் எர்த்துக்கு எப்படி அக்வயர் ஆகுது இல்லையா. அதுல ஃபர்ஸ்ட் தியரி, or the first person to discover this property, Earth's magnetism property, or Earth has magnetic field discovery, was brought in by Sir Gilbert. Very important personality. Okay, Sir Gilbert, he was the one first suggested that Earth has magnetic property. But what he believed, according to him, he suggested that there is a huge bar magnet embedded in the center of Earth. He very strongly believed that Earthக்கு உள்ளேயே ஒரு பெரிய magnet இருக்கு. Entire Earthக்குள்ள ஒரு பெரிய சைஸ் மேக்னெட் இருக்கு. அந்த மேக்னெட் இருக்கிறதுனாலதான் என்ன கிரியேட் ஆகுதுன்னு சொன்னாரு, மேக்னெட்டிக் ஃபீல்ட் லைன்ஸ் கிரியேட் ஆகுதுன்னு சொன்னாரு. Okay, magnetic field lines are generated due to a huge bar magnet embedded within the Earth center. How relevant is this theory as now? This is very inaccurate to describe the Earth's magnetic field because it is subjected to change. Permanent or magnet ulla irukku அப்படினா அப்ப என்னோட magnetic field lines எப்படி இருக்கணும், permanent இருக்கணும். Magnetic field lines permanent இருந்தா என்னோட magnetic properties எப்படி இருக்கணும், அதுவும் சேம் ஆவே இருக்கணும். ஆனா Earth பொறுத்த வரைக்கும் அப்படி இல்ல. We now know there is reversals of pole happening, very evident thing happening now. Okay, Canada la irundhu it is moving towards Siberia. So permanent or magnet இருந்தா அப்போ இந்த மாதிரியான changes நடந்திருக்க கூடாது. So the entire theory became irrelevant. But one credit that he is the first person, or he was the first one to describe such a property to to Earth. The second is rock magnetism. There is one prominent theory which revolves around the concept something like Earth is made up of rocks. ரொம்ப சிம்பிளா layman terms நம்ம புரிஞ்சுக்கலாம், ரொம்ப டெக்னிக்கலா போக வேண்டாம் unless until your optional geography, right? So Earth is made up of rocks which have magnetic property. That is very true. There are some rock particles which exhibit magnetic property naturally. Okay, so rock magnetism ஒரு fact தான், it is very true. ஆனா Earth பொறுத்த வரைக்கும் இந்த அளவுக்கு ஒரு higher magnitude, higher intensityல geomagnetic property exhibit பண்ணனும்னா அந்த rockோட concentration அதிகமா இருக்கணும். And we all know the Earth's interior is, the temperature of Earth's interior is so high. What will happen to the rock? The rock would have been molten down. Melt ஆயிருக்கும். Okay, so that theory was also been nullified. So these are two important theories. Yes, Gilbert theory and rock theories. Gilbert theory and the rock magnetism theory had its own loopholes that it does not give complete answers to all the questions. Then came the most important theory, or the most recent theory, what we call as the dynamo theory. Okay, so dynamo theory, these names are again important. It was propounded by the American physicist known as Walter M. Elazar and the British geophysicist Edward Bullard. Two important personalities. And this theory is also easy once we know the structure of Earth's interior. So I'll try to explain it in a very simple terms. We know that the Earth is made up of different layers. The outer layer is crust, the intermediate layer is mantle, and the innermost layer is your core. This layered arrangement is based on the density difference, right? The least dense elements are arranged in the outer layers, and the most dense elements are concentrated in the Earth center. And the core has a specific property. The inner core is in a solid state, and the outer core is in the molten state, molten or plastic state. So this is a solid state core and this is a molten state core. Molten meaning the rocks are all in the molten state, or for this particular understanding I must say these are all in ionic state. Okay, elements ellame ionic state la irukum. And we all know core comprises of the most important dense metals like iron and nickel and other traces of other elements. Magnesium la irundhu ellame irukum, but dominant iron and nickel. So what happens? The molten iron or the ionic ions, they rotate around the solid inner core. Okay, so there is rotation or movement of ions in the outer core. Movement of ions or movement of electrons would result in what? They result in electric current. and what we call this as the eddy currents. Okay, so or solid, and the solid is again made up of conductor or the same metal, and it is been surrounded by currents. So what will happen? This particular core would induce magnetic field. Okay, this will induce the magnetic field because of the outer core, which is in molten state, and in the molten state the rocks are in ionic state, or they are free to move. When electrons move, they generate electricity. So the eddy currents would create or induce magnetic property to this particular core. Okay, this self-sustaining dynamo சொல்லுவாங்க. ரொம்ப நார்மலாவே பிசிக்ஸ்ல we have a solenoid. Solenoid அப்படிங்கிறது இதுவுமே ஒரு டிபிக்கல் solenoid மாதிரி தான். அது எப்படி ஃபங்க்ஷன் ஆகும்னு பாருங்க. If a metal or any conductor is been placed in a current carrying coil, ஒரு கரண்ட் கேரிங் காயிலுக்குள்ள ஒரு கண்டக்டரை பிளேஸ் பண்ணோம் அப்படின்னா, இந்த கரண்ட் கேரிங், தட் இஸ் தி எலக்ட்ரிக் ஃபீல்டு சப்ளைடு, எலக்ட்ரிக் ஃபீல்டு கொடுக்குறோம். ஒரு கண்டக்டரை சுத்தி எலக்ட்ரிக் ஃபீல்டு இருந்தா, திஸ் கண்டக்டர் வில் ஆக்ட் அஸ் அ மேக்னெட், will act as a bar magnet. Similarly, earth oda inner core is solid. Assume that is the conductor, and outer core is in a molten state. And what is happening inside the molten state? The ions are in mobile fashion. They are producing eddy currents or electric currents. So similarly, eppadi or conductor electric carrying coil kulla vecha magnetic property induce panna mudiyumo, ingeyume because of the electric current produced in the outer layer, magnetic properties are induced into the core. Of course, this theory answered most of the questions, but it also lacked one important area. It failed to address, that is why there is fluctuations in the magnetic field and reversals of polarity. We all know reversals can happen, it is a possibility, but why it is happening? Even this theory, which is the most recent theory, which is the most relevant theory, which answers most of the questions which the earlier theories couldn't explain. முன்னாடி சொன்ன theories எல்லாமே நிறைய flaws இருந்தது, இதுதான் இருக்கிறதுலே recent theory. Okay, இவங்களாலுமே எதை explain பண்ண முடியல, the fluctuations in magnetic field and the reversals of polarity explain panna mudiyala. So this is the simple explanation of your geomagnetic theory. Okay, now what is the very important purpose? As we dealt earlier, this field will protect earth. As you can see in the diagram, edhukku specific la kuduthirukena, you can find that even though the magnetic field lines are closed loops, they are not uniformly distributed. In one half, the magnetosphere is relatively smaller, and the other half, it extends to a larger distance. So magnetic field line eppadi irukum actually? Okay, you're getting me? One side it has been elongated. Why? Because of the impact of your solar winds. The magnetic field line facing the sun would be shorter, and the other half would be quite longer. As you can see, this is an open source. I downloaded it for a better understanding. These are solar wind. Solar wind magnetic field oda react பண்ணும்போது it acts as a shield. Okay, and maximum expression or impact of this is felt in this polar region. As you can see, I can repeat here. So polar regions la இந்த இடத்துல, when they meet the magnetic field lines and the solar flares, you can find the phenomenon of lights, exhibition of lights, and this is what we call as the Auroras and Aurora australis. Auroras nu solluvom. Especially these are found in the regions of higher latitudes, that is beyond the Arctic Circle, that is 66.5 degree north, and beyond your Antarctic Circle, half degree south. Aurora borealis and Aurora australis. Borealis is what happens in your northern hemisphere. Australis அப்படிங்கிறது the northern lights which are visible, or the polar lights. which are visible in the southern hemisphere. Okay, beautiful expression. These are nothing but the reaction of the ion, solar wind la irukkudiya gamma rays irukku electromagnetic rays. And the electromagnetic rays inoda atmosphere la irukkudiya ions inoda magnetic field line சேர்ந்து react பண்றதோட outcome தான் அது. Okay, so lastly, the significance. Why geomagnetism is important? First and foremost thing, it acts as an indirect source to understand the interior of Earth. It acts as an indirect source. And earlier, okay, historically, without the full knowledge of geomagnetism, this also acted as an important quest for new trade routes, okay, in navigation and the formation of auroras, right? Solar winds from sun contains plasma or the gamma rays, which reacts with ions in your mesosphere and it emits electrons, creating beautiful, colorful sky. Okay, mesosphere and to some extent in the ionosphere too. Lastly, communication. What happens? The geomagnetic storms are very intense or stronger geomagnetic field lines. What it can cause? It can cause the failure of your electric system or your electric communication networks. So the transmission of electrical energy could be affected. Okay, so these are the most important significance of your geomagnetism. Okay, so very basic. We are not moving into the in-depth of each and every topic here. So we have dealt with the basic area and some conceptual area. So lastly, we're going to revise this topic with the help of few questions. Okay, try to answer this. Only 3 objective type question. So the first one, first question, you can take a moment or you can pause the video, look into the questions deeply and try to answer them. During a geomagnetic pole reversal, the magnetic field, what will happen to the magnetic field when the poles are reversed? Okay, through the questions also, we are trying to understand some concepts. First option, become stronger and more stable, weakens and become chaotic, remains completely unaffected, reverses instantly without any consequences. Yes, the answer is B. It will weaken and it will become chaotic, right? The polar reversal is a very complex phenomena. Obviously, it will create some chaos in your magnetic field line. Second question, the magnetic field lines around Earth. What are those? They are always straight and evenly spaced. They form closed loops that extend from the North Pole to the South Pole, only exit in the Earth atmosphere, are influenced by the phases of the moon. From the very beginning, we are very clear about it. Like they are closed loops, extend from North Pole to South Pole, obviously, but the distribution of magnetic sphere is not even, right? It is elongated at some regions. Next, third question. Consider the following statement. There are 4 statements given, 4 statements given, and you need to answer the question. First one. The Earth's magnetic field is solely generated by the movement of molten iron in the outer core. Geomagnetism has no practical applications and is only for scientific interest. Geomagnetic pole reversals have no impact on Earth's climate or living organisms. Solar activities such as solar storms can influence Earth's magnetic field and geomagnetic activity. Shall we? You can pause the video, think for a moment and try to answer. Right? First statement is wrong. Why? It is solely generated by. It is not, it is primarily generated by, or the most important factor for generation of Earth's magnetic field is the movement of molten iron in the outer core. It is primary factor and not the only factor. Solely na meaning it is only because of artham. Okay, so the first statement is wrong. Second, geomagnetism has no practical applications. No, this statement is also wrong. Third, geomagnetic pole reversals have no impact on Earth climate or living organisms. Again, no. What about the last one? Solar activities such as solar storms can influence Earth's magnetic field and geomagnetic activity. True. Okay, if the fourth statement is true, then first is obviously wrong. So the answer for this is A. Only one statement is true. That is your fourth statement. That is your fourth statement is true. All 3, 1, 2, 3 are wrong. Right? So this is your answers. For question A, B, question 2, B, and question 3, the option A. So I hope this class is helpful. Okay, please leave your valuable suggestions in your comment section and do subscribe the channel for regular updates. Thank you all. Happy learning.